Okay, so this is the second video. We're going to look at evolutionary patterns. Four basic patterns: co-evolution, mutual evolution between two species, predator-prey relationships are a good example of this. Convergent, which we see over here, two unrelated species evolve in similar ways. They converge. Divergent, we see over here, where two related species evolve in ways that makes them appear less similar. And there's parallel evolution, similar evolution changes in two species that can be related or unrelated. Okay, my example of coevolution is in Wood Buffalo National Park. This is in northern Alberta, where the largest wolves in the world occur because of the largest land animal. So they exert selection pressures on each other. The predators are large because if they weren't large, they wouldn't be able to bring down a 1-ton male bison, for example. Okay, so they exert selection pressures on each other. These are both biotic selection pressures. As a result, those wolves that are large survive. And this exerts a selection pressure on bison that are also large, obviously to a certain extent. And you see this also with moths and bats. Fascinating examples of coevolution where the moths have learned to evade bats, and it's a cat and mouse game, one catching up to the other evolutionary speaking. So they co-evolve together. Predator-prey relationships are significant for this. Convergent, the independent evolution of similar analogous um, features in distantly related species. Now we're going to talk about the analogous features a little bit later on. So arises when groups independently adapt to similar environment. So we've got two different species. They're going to converge. They're going to have similar pattern shapes. So take a look at, for example, a sugar glider in Australia. It looks very much like the flying squirrels we see in Edmonton if you go out for a walk at night in the river valley. Okay, they look very similar, but they have different ancestors. They're not closely related. They've evolved in different land areas, but similar selection pressures. Similar selection pressures means that their form looks the same. Birds and insects look the same, but obviously one's insect and one is a bird. Similar selection pressures, but different origin. And convergent evolution, these are just some things that Darwin observed, okay, between placental mammals. They have placentas and marsupials, which are pouched mammals. Wolves, Tasmanian wolf, ocelot, a quoll. We talked about the sugar glider and the flying squirrel, lemurs, mice, dunarts, anteaters, numbats, marsupial mole, and mole. They look the same, but they have, because of similar selection pressures, but they have uh, come from ancestors that are distant, very distant. So evolving to become similar. Similar variations would be favored by natural selection to enable them to survive and breed in similar conditions. Divergent is, as it indicates, parent species that diverge. Two related species evolve in a way that makes them less similar. This can lead to new species. Differences in closely related species occur due to different selection pressures. So there's the original hand. But look at all of these. One is for grasping, for trotting, for digging, okay, for swimming, for flying, but they're all mammals. Yet they look unrelated. Common ancestor, They diverge. Different environments, so different selection pressures. And related to that is the word adaptive radiation, rapid series of speciation events that occur when one or more ancestral species invades a new environment. Now, that was Darwin's finches. We have all of these different species of finches that we looked at last week that came from the mainland, South America, and they diverged onto all the different islands that we looked at last week. Okay. So species adapt to a narrow range of environmental niches. Okay, so each one of these islands has slightly different selection pressures, those that favor seed eating, those that favor insect eating, and so on and so forth. They radiate it out. That's divergent evolution. Divergent and okay, and you can read through that. Okay, so let's take a look at this. Is this convergent or divergent? It is convergent. A dolphin is a mammal. A shark is a fish. They look similar because similar selection pressures. What would be the main selection pressure here? Drag. Okay, water moving over. It's faster if the body's streamlined. So even though they've got different evolutionary origins, mammals and fish, the same selection pressure. They've got to swim through water. It provides drag force. Okay, and this one here, it just identifies that. Okay, this is divergent evolution. They came from mammals, but they look different. And this is convergent evolution. Came from different ancestors. They look similar. You can see this with boas. Boas and pythons. They come from different continents. Very similar. Divergent evolution we looked at, monkey, whale, and pig, they all come from mammals. Eyeballs, is that divergent or convergent? Here's a cephalopod eyeball, here's a vertebrate eyeball. Convergent evolution. They come from different ancestors. We share a common ancestor, but way, way back in the evolutionary tree. So similar selection pressures provides for similar structures. Convergent evolution. Divergent evolution, adaptive radiation. In parallel, two related species arrive from a common ancestor. The two species then evolve much the same way, probably in similar environmental selection pressures. Okay, and we'll end there.